Okay, we want to find all possible rational zeros of this function and then find the actual rational zeros, and we'll factor it too, so we can get kind of a full rounded idea of how this question works. So again, if you apply that rational roots function, we want to focus on the last number as well as the first number, really coefficient. Again, this is in descending order. That is a very important piece of this. So values of p, well, factors of 30 are plus or minus 1, 2, 3, 5, 6, 10, 15, and 30. It's a fairly long list, especially compared to other examples that we've seen. But the nice piece of that is our candidates for Q are just 1, because this is just a 1 sitting in front of that, right? So even though P is a longer list, Q is really short. So when it comes to what's P over Q, and this is what the first part of your question is asking, I guess I called it a 1, didn't I? The first part of your question is asking, you're just essentially going to list P again, right? Because we're dividing everybody by 1. So plus or minus 1, 2, 3, 5, 6, 10, 15, and 30. So that is your first part of your answer. Not a very well drawn box, as you can see. So that's the first part of your answer. Okay. Next up, we want to determine which of these are actual zeros, actual roots of this polynomial. So to do that, honestly, let's just rely on synthetic divisions. I'm going to just go down this list. You do not have to go in order. You're more than welcome to, kind of just pick and guess as you go. But again, this is the list we're working off of. So I'm going to just start with 1. I've got 1 for x cubed, 6 for x squared, -1 for x, and -30. So bring this down. 1 times 1 is 1. Add and get 7. 1 times 7 is 7. -1 plus 7 is 6. 1 times 6 is 6. And I'm mostly interested in this is not 0, right? We can put -24, but this is not equal to 0. So this is not going to be a 0 of our polynomial. Let me cross it out in another color. Okay. So let's just try another number. Let's try -1. So same values, 1, 6, -1, and 30. So I bring this one down. -1 times 1 is -1, plus 6 is 5. -1 times 5 is going to be -5. -1 plus 5, -6. -1 times -6 is +6. 36. Again, still not equal to 0, still crossing it off our list. This is a good example because, sometimes it takes a minute to get to your answer. We have 2, 4, 6, 8, 10, 12, 14, 16 different options. So you're not guaranteed to get the right one on the first try every single time. Let's try 2. 1, 6, -1, and +30. Oh, -30. This is also -24. See why it's important to be really careful. -6, 5, 6. Okay, we're good. So -30. Okay, so I'm going to bring my 1 down. 2 times 1 is 2. 6 plus 2 is 8. 8 times 2 is 16. Minus 1 is 15. And 2 times 15 happens to be 30. So when we add this, we actually get 0, which is great for us, right? So this means that this is, in fact, one of our zeros of our polynomial. So I am going to instantly remember, okay, so maybe we'll keep a list of our zeros. 2 belongs to that list. I'm also, though, going to rewrite this. So this means g of x is equal to x minus 2, remembering our notation, right? And then I've got x to the, we started off with third power, so squared plus 8, x plus 15. Now, again, I have the option from here to either keep factoring, right? I can even do a whole new list if I want. With 15 here, P over Q is a much shorter list because P would be plus or minus 1, 3, 5, and 15. Write that better. 15. And Q is still just plus or minus 1. So that means P over Q is that same list, right? 1, 3, 5, and 15. So you can actually kind of restart this, reboot it if you'd like, but it works just fine if you work off of your original list. We don't have to throw this original list away, okay? So from here, your other option, and I think I did this in the last example, is really to just continue factoring, right? If you're able to look at g of x, knowing this is x minus 2, if you're able to continue factoring this and just do it using your box method or, guess and check or whatever your approach is, then go for it. I'll continue this one using just synthetic, just for a little bit of consistency. And I'm actually going to work off of this new list that we found right here. So we already tried our ones. Maybe I won't try them again. I can circle back around to them if I need to, but let me actually just start with the 3. So if we do 3, we've got 1, 8, and 15, right? So 1 comes straight down, times 3 is 3, plus 3 is 11, times 3 is 33. It's definitely not 0. Right? Okay, so 3 didn't work. Let's try someone else. Let's try negative 3. Okay, 1, 8, 15. So 1 comes straight down. Times 3 is negative 3. 8 and negative 3 is 5. And 3 times 5 is negative 15. Hey, what do you know? We got another 0. So this tells us, I'm going to build off of my previous list. I'll box it like I did my last one. So this becomes g of x is the x minus 2 we already had, right? That was the previous group we did. And then this tells us, remember your opposite sign, so x plus 3. And the only thing that's left is x plus 5. We already knew from the previous example, or previous part of this example, right? Our zeros are x is equal to 2. We just found negative 3, and this tells us negative 5. Okay, so our 3 zeros are 2, negative 3, negative 5. Okay, the linear factors is this list right here. I guess I should keep this part of it. Okay, hopefully that makes sense, and I will see you in the next example.